This video has been sponsored by NonWash Networks. For more information on the NonWash Virtualized Services platform and how NonWash is delivering consistent policy-driven automation across data centers, the WAN, and branch locations everywhere, please visit nonwashnetworks.net and follow us on Twitter at NonWash Networks. We hope you enjoy the session.
After watching this video, visit ipspace.net/sdn to learn more about software-defined networking and overlay virtual networks. So the concept of security groups is very simple. We want to replace the traditional firewalls that were choke points placed between individual subnets with something that scales out. It could be packet filters, it could be full-blown stateful firewalls or something else. But the idea is that we have a filter in front of every VM, so we don't have the central choke point anymore. Also, with this, we automatically increase the security inside a segment or subnet, because previously these two VMs could talk to each other. Now, if the firewall says, no, you cannot talk to the other orange VM, they cannot. And because we don't need subnets for security separation any longer, there are no addressing limitations like previously we could only have web servers in this subnet and database servers in the other subnet and so on. A lot of orchestration systems support the security groups, for example, CloudStack, OpenStack, or VMware products. The problem is that not all implementations support the concept on all hypervisors. So you have to be a bit careful when choosing the orchestration system. For example, CloudStack can support security groups, but it cannot do that on Hyper-V or VMware, even though both now support access control lists, because people just haven't coded that in CloudStack yet. Anyway, high-level view of security groups is very simple. You assign VMs to groups, you specify filters between groups. For example, you may say from anywhere to the web group, you can work on the two HTTP ports. Between the web servers and the app servers, you can communicate on the port 9000, and between the app and the DB servers, you can communicate on the database port. And from the management segment, I can talk to all VMs on the SSH port. Simple. Typically, these things are implemented as a packet filter, either with Open vSwitch or with Linux IP tables. And because I can have many web servers talking to many app servers, this thing might get pretty long. Now, if you are using IP tables, there is a new tool called IPset, which allows you to specify sets of IP addresses in individual rules in the IP tables, and supposedly it is pretty good and fast. If you're using traditional access control lists, you will end up with what mathematicians call a Cartesian product of IP addresses. Now let me explain how that works. Let's say we have 3 web servers and 2 app servers. The first rule from anything to the web server is actually exploded in 3 lines for every individual IP address in the destination security group. Same thing with the second one, and the third line is exploded into 6 lines. Well, you would say, well, this is all done in software, so who cares? The problem is that access control lists are usually scanned linearly, so you go through the rules in sequence, which means that for long access control lists, you will get a performance impact, and performance is usually inversely proportional with the length of the access control list. If your implementation deploys the same expanded access control list on all VM NICs, well, yeah, too bad. You will get even worse performance. And this may or may not matter depending on how you implement things. Any change in security group membership obviously changes the content of this access control list, which then has to be propagated to everywhere. NonWash has an interesting solution here. They said, well, why don't we mark the security group membership with the BGP community? So for the local VM, attached here, I know what a security group is because it's attached to my port. For remote VMs, why wouldn't we pass the security group of the VM with a BGP update? Now, obviously, for this to work, you have to trust the other BGP peer. So this only works over a trusted control plane infrastructure. Don't do that with your competitor. Typically, you would start a new VM on hypervisor. The VRS, the virtual switch, would notify VSC that, well, we have this new port active and there's this new VM on it. Then VSC would notify VSD and ask VSD what to do with it. And then VSD would tell VSC that, well, this new VM should go into that new security group. And VSC would update the forwarding entries on all the VRSs to implement the new security group model. The question here, so does this mean that you run BGP between the controller and every VRS? No. BGP is only run between the controllers, and OpenFlow is used to push the information to VRS. But with the OpenFlow extensions, or I think they use metadata to do that, in any case, in the OpenFlow entries, there are rules to match the security group membership that is specified in the BGP community. When you do that, because the rules between the groups haven't changed, the access control list on other hypervisors doesn't have to change. If we talk about security groups across availability zones, then obviously after the thing from the previous slide happens, now VSC would update the MAC to VTAP and IP to VTAP mappings, and it would include the security group in that. And then it would send a BGP route to the other VSC with the BGP community being attached to the new EVPN or IPVPN based on what you're doing update. Send the update to its BGP peers, and then the other VSC would use OpenFlow to update the forwarding entries, the mapping between MAC or IP addresses and security groups in the VRS, but the access control list itself wouldn't be changed. So this is more or less equivalent to what you get with IPsec on IP tables, but it's implemented with BGP and OpenFlow. Security groups typically talk about policy, but does not take in account other functionality where data plane state are required, like replay attacks and so on. That is absolutely true. Security groups provide ECL-like functionality. Whether that's good enough or not is a different story. As I said before, for most modern TCP stacks, that's more than good enough because the TCP stacks themselves have been hardened through the last 30 years of attacks. If you think that you need a fully blown stateful firewall, if your security policy dictates that, or if you're running an original Windows XP with no service pack on it, then obviously you would need more. Also, I would put a stateful firewall between my data center and the global internet if required, or maybe between my application and the global internet. But within the application stack, ECLs are usually good enough, particularly if you patch your systems at least on some occasional basis. Finally, let's see how security groups work in the data plane. So a VM would send an IP packet. The IP packet would hit an ingress access control list. And here we know that the from security group is the VM NIC group, and the to security group would be derived from the BGP communities. The encapsulated VM frame is sent across the transport network. On the other end, the packet hits another access control list where the from security group would be derived from the BGP community derived information, and the to security group would be based on the VM NIC group. And then the packet is delivered or not delivered to the target VM. Across multiple domains, you can use BGP communities and maybe even extend the whole thing across an MPLS VPN backbone, which means that if you trust the MPLS VPN backbone to do proper tagging of prefixes, you can extend that trust into your cloud environment. Now let's say a VM would send a packet to a remote host. Ingress access control list on the VRS would kick in, and here we can match on the security group of the VM and the security group of the destination based on the BGP community. And then the packet is delivered to the remote host. In the reverse direction, obviously there is no check at the source because we have no control over the WAN network. But when the packet is delivered to the VRS, the egress access control list on the VRS will kick in and may block the packet from getting back to the VM or not. Does NonWash Networks use reflexive access control lists or act as a real stateful firewall? It uses reflexive access control lists. If you like this video, go to ipspace.net/cloud to explore other overlay virtual networking webinars.